Hello, everybody. Thanks for joining me here again. I just wanted to create another quick and short serial tutorial. Hopefully, it will be useful to some of you out there. I wanted to showcase some of the new features that Siril has. In this particular case, I'm using Siril version 1.4.0, and it's honestly really good. Once again, Serial is completely free. You can just download it from the website. I'm going to put the direct link in the video description. And let's get started, right? Okay, so what I wanted to show here is I picked this particular image because it's very interesting the way that it turned out to be. So when you open the image, this is the image from the Deep Sky Stacker. We wanted to see what we have, right? So we go to this particular option here in the display mode, and we go to auto stretch. And in here you will see two things. One, you will see the stacking artifacts. That's why it's definitely very important to match every single live frame or as many as you can of every night session or every session that you have, so you don't have this particular problem. And the other issue, which is even more obvious, is the color, right? If you're using a one-shot color camera, then you will typically see this like this, or sometimes red as well. In this case, for color cameras, is because most color cameras have 2 green pixels, which will, in this case, saturate the green channel. And then when you stretch the image, Serial, what it will do is will try to balance all the channels equally or stretch them equally. And because we have 2 green pixels, and it will create this particular problem, but don't worry about it. It's something that we can correct on the final image and right now as well. So what we need to do is we need to unlink the channels. So click on this icon here. That will unlink the channels, and now they are not the green channel is not overpowering everything. So the other problem that we have here in this image is that we need to crop it, right? And typically when you use to crop it on the previous versions of Serial, you can create any rectangle or square, but sometimes that wouldn't work, right? Sometimes let's say that you have maybe something here that you wanted to keep, but then that will mean that it will also include an artifact, right? Or what if we make it maybe a little smaller, let's say like this, right? And you wanted to crop it here, but then it will include all this corner that is ugly, right? So then now this new version of Serial, it has the option that you can crop and rotate. So what you can do is right click the image anywhere in the image and go to the crop menu, and then the sub menu is rotate and crop. You will see that now you have a different highlighted area, which is in red here, and what you will do is just click here on this slider and then drag it the slider, so you can try to match or better match the framing to your image. So let's say let's pick this particular shape. And you will see that you have as well a dotted line that represents the original framing that you did, the original highlighted area. But as you can see, the red frame now is bigger than the actual image. So what you can do is just reduce it, drag it, click and drag, and then you can reshape that final highlighted area. All right, so we go here. Let's slide it here. This one maybe a little bit. I don't think that's gonna work there. Here maybe a little tighter. As you can see, I have another stacking artifact here. I think maybe I wanted to include that star. That's pretty star. Okay, so we can click here there. I think that's fine. We can click and apply. Perfect. Here we go. That will crop the image without including the stacking artifacts, which is awesome. Okay, so we now close, and now we can start processing the image. Right, so before anything else, let's click here, image processing. Let's go to remove green noise. Right, so if there is any problem in there of any star or any hint of green that was not balanced before when we did the unlink, then we can do it here. Sometimes as well, if there is any light pollution, it might look a little uneven on the image as well, so you can take care of that here. So I typically just leave it here in the default settings. Just click on apply. That's close, right? As you can see, it changed the tint of the image. So if we go to link again, that definitely doesn't look right. So let's go back. Let's go back here, and then we can go back to this image. We know for a fact that this elephant trunk nebula, it looks like this, right? It has a tons of hydrogen alpha, so it should be pretty red. Um, so let's move on. So let's leave that. So as you can see, I want to show that too because um, you can see sometimes it may work, sometimes it may give you a weird result. So you don't always have to use it. All right, so let's go back to image processing, background extraction. Right, in this case, I did the images. So let's lower this so it won't pick by accident any parts of the nebula, and then we click on generate. Right, what will happen is sometimes if you leave it as the default, I think it's around 1 if I'm not mistaken, but let's leave it here. Let's increase it. As you can see, it starts to include parts of the nebula as the background, which will remove, and that's something that we definitely don't want. All right, so we can go here and generate, and if it's still stubborn, you can keep going lower, or you can right click any of the highlighted areas, and uh, uh, that will remove any of the sections here that is going to use as the background model. All right, so let's go here. All right, that seems pretty good. So we go to subtraction, and then click on apply, compute background. Okay, so here we go. That honestly looks pretty good. And then we can compare how it looked before and after. Before, after. All right, so definitely it's making the change. Now we can go to division. Let's click on apply. Nope. Sorry, I don't know what happened there. Background instruction. Compute background division. Yep. Let's generate. Compute background. All right. Let's see. Before and after. Okay. So that looks pretty good. Let's go and apply. All right. And that's how the image is turning. Definitely need to have more data for these images. You can see it's super noisy. If we go here to check the individual channels, red, like I said earlier, tons of HA, hydrogen alpha, definitely not so much oxygen, and blue is pretty much noise. Is quite useless, right? And that will create definitely a lot of noise. So there's two things that you can do here. You can hide the noise if you don't stretch the image too much, but that will also hide the details. And sometimes because of the weather, or maybe one thing or the other, you didn't have enough time for integration, so this may happen. All right, so what you could do here, what I will do personally in this particular image, if I wanted to really use it, is I will just separate the red and green channels, right? Because the blue in reality is just pure noise, and definitely you can see at the end how it's affecting the image. Right, so let's try to see what we can do here. So let's go to tools. Sorry, image processing, channel extraction. Let me go to split channels. Okay, we're gonna call the channels, you can call them however you want. I'm gonna call them HA, and then O3, and then none. It doesn't matter the blue, but I'm gonna just not use it at all. We click on apply, and that's it. That's split of the channels. Now we can create a new image with the channels that we just split it. So once again, we go to image processing, then we go to composition, RGB compositioning. That's very strange wording. Yeah, it's going to ask us if we want to close the image. We click on yes. So in this new menu that opens up, what we need to do is pick the images of each individual channel. So in this case, the channels that we split earlier, those images are going to be saved automatically to the location where the original image was opened from. So in that way, it's very easy for us to find them. So we click in here. We're gonna pick each of our channels. So in this case, I'm gonna select. I'm gonna go with HOO palette. So I'm gonna select HA for red. I'm gonna select O3 for green, and I'm gonna select again O3 for blue. And that's it. That's the final image created. And it definitely looks a little better, I will say. Right now you see that there's a little bit of imbalance here because now the background doesn't look black or dark. However, I think it looks a little better compared to what we used to have. Right? It doesn't look as noisy. So the next step now, what we need to do is color balance the image. In order to do that, I would recommend to always use a spectrometric color calibration. So what we do in this case, we need to placeholder our image. And for that, you will need a couple things. You will need to know exactly the name of the target that you were shooting, nebula, globular cluster, or anything like that. You need to know specifically the number or the name of the catalog. And as well, you will need to know the focal length of your telescope or lens or camera lens, and as well the pixel size of the camera that you were using. If you were opening a FITS file originally, that information will be saved in there most of the times. But in this case, since we created a brand new image, that information, sorry, may not be transferred automatically. So let's take a look. Before we do that, we go to Tools and then FITS header, and that information, let's see. Actually, it is actually here. That's excellent, right? You can see the camera, the sensor temperature, gain, and other things there. All right, so let's come close. So now what we can do here is let's see if Siril's smart enough to be able to pick that information from the FITS header. Image processing, color calibration, and these options are grayed out. So even though the header has that information, Siril doesn't know that, and I haven't found a way to tell it, okay, read the header directly. So what we need to do, like I said earlier, is placeholder the image. So we go to Tools, Photometry, Tools, Astrometry, Image Placeholder. So in this case, we enter, like I said, the name of the target. So in this case, it's IC1396 for the elephant trunk. We'll click on Find, and that will get the coordinates from this particular catalog. And then from here, we enter the focal length of the telescope or the camera and the pixel size. And then you can click on OK. If we go here to the wow, that's crazy. To the console, then you will see that is here. It flipped the image, I think. Let's see. Yep, it's sold the image already. Okay, so that's where you'll be able to see that information. Sometimes you may get an error that it says that it cannot placeholder the image. And let's take a quick look back again on that image placeholder. So sometimes you will need to play around with the focal length. For example, my telescope is, another telescope that I have is 335 millimeter focal length. And sometimes if I enter that, and even though I know it's right or should be right, and the pixel size, it says that it cannot solve the image. Right? You will see that in the console, that it cannot find solution or something like that. If that is the case, play around with the focal length. You can go 100, 200 millimeters up or down. Try to play around with that. Sorry, for the pixel size, you can also try going a little bit higher, a little bit lower. But typically, most of the times, just playing with the focal length should be able to help you to placeholder the image. Sometimes as well, if you drizzle your image, let's say to 2 times or 3 times, then although technically the only thing that is changing is the resolution of the image, you will also need to adjust the pixel size or the focal length. So let's say you went 2 times, then you will need to double this number or double the pixel size. right? Or if it went 3 times, then you need to triple this number and so on, right? So it will match and we'll be able to solve it. So let's try, for example, here. Let's put 400 millimeters. Just to show you what happens if sometimes you cannot play it off. So go to OK. It will start to connect and see you will get this error. Right? They cannot be online, and sometimes it's very frustrating. I know, but it's getting pretty good actually. The one that is giving me issues is PixInsight now. When I do the image solve, Siril pretty much every time works now, so which is excellent. So let's enter here the focal length. Actually, I'm using a Rokinon 135S2. So let's put that information there. Let's open the console again, and you see the image is played solved now. Perfect. So then we go to image processing to color balance an image, color calibration, spectrometric color calibration. We click here. Honestly, I play with these settings here where you can select the specific filter that you're using. I tried different ones, and honestly, I cannot tell the difference, so I'm not so sure what it's really doing. I think it's trying to perhaps balance the image more accurately, but honestly, I haven't been able to tell any difference from one or the other. But you know, probably is doing something that I'm not so sure, and let's just try to use it, try to match the filter that we may have. So let's select here. In this case, I was using our Antli. I was using the quad band actually, but in this case, let's just leave it like that. Oh, sorry, no, actually, I was using a 5 nanometer filter. So since that particular filter is not here, I'm just going to select this one, and it should be fine as well. If your sensor is in here, please pick it. So what it will try to do, will try to match the stretch of the curve, not the stretch, sorry, the balance of the colors to match the dynamic range of your sensor of your particular camera. So in my case, I have the IMX 183. I'll select that. I always click on here as atmospheric corrections. This honestly, I cannot tell the difference if it's actually doing anything at all. But I don't think it will hurt to do that. So let's place this information here. The barometric pressure of your particular altitude. So in this case, in my location is 1020. Actually, if I can enter in here, and then we click on OK. And then on the console, it will start trying to play solve the image. So I'm going to pass the recording because typically this takes, a couple minutes at least. Okay, I'm back. So this particular process takes a couple minutes, right? So just leave it running, and then once it finishes, it's going to create these graphs. These graphs will look different for galaxies or nebulas or star clusters. So what it's trying to do is trying to use the stars with information from different online sources, using the stars as the white point, as the white balance, instead of using perhaps the brightest point, which in this case will be the nebula, as the white reference. So in that way, we can get a more accurate color of the particular target that we're shooting. That's all that this is trying to do: a more accurate color and white balance of the image. So in this particular scenario, we can close this. We can close as well this menu. In this particular scenario for this nebula, it doesn't look like it changed too much in when it comes to color or background, and that's okay. Right? Sometimes we are very close to the actual real color of the target, and you may not see the difference, but some other times you will. Right? So it depends on the image. So if we go here between back and forth, it doesn't look like much change, if anything at all, right? And that's okay. So now the next thing will be to stretch the image. And to stretch the image, we have the two methods. One of them is quite simple. That is the statistical stretch, which will do it automatically for us, right? We'll try to balance the lighter areas with the darker areas, balance the highlights and the shadows, and try to give us a good final image. And the other one that we can use is generalized hyperbolic stretch. So I'm going to show both. So let's start with the easy one first. So if we go to scripts, Python scripts processing, then we look under the S for statistical stretch. So we click on it, and that will bring this menu here. Um, and before we apply any changes, we need to change the display mode to linear again, because remember, right now we're stretching the image just to see what we had, but we need to bring it back to linear. If not, it will be hard to tell the difference between statistical stretch and auto stretch. Okay, so in here, target median, it will try to find a balance between highlights and shadows. So we'll give us a middle of the road kind of result. We can always try the slider, right? Different settings. We can also click here in link stretch. So in that way, all three channels are balanced evenly. That's what we need to do. And normalize, we'll try to balance the darker areas with the highlights. And as well, you can apply a boost to the color. I typically don't do this because I think the way that Siril has an option for that, I think is better. And as well, if you have access to other tools like Affinity Photo, Luminar, or Photoshop, it might be easier in those programs to select a specific color and just boost that one than like a general color boost for everything, which will also boost the background. So I'm just leave that one on check. So let's click on apply and see what that's going to give us. Um, I think that's too dark for my taste. So I think we definitely need to stretch it a little bit more. So let's go to 0.24. Um, and as well, something important here is if you go and apply again, it's going to apply that on top of the original stretch that it did. And that's something that you don't want to do because sometimes it may overdo it, right, very quickly. So what you need to do is you need to undo the change and then try it again. Go to apply. That's kind of getting there. I'm not too satisfied with that. Let's try a little bit more, perhaps 0.27. Apply. I think that looks kind of okay, but also the background is like too white for my taste. Right? Remember, you don't want a black background, like pitch black, because definitely sky is not like that. However, space is not like that, sorry. However, it might be tempting, right? Sometimes to go like that, all black background. So we don't want that, but this is way too overexposed in my opinion. All right, so let's try maybe here a little bit lower. Let's click on apply. And that might be too dark. Let's try this again. Apply it on top of what we already had. You don't want to do that, remember, but in this particular scenario, it may work because it might just give us enough of what we need, and I think it's doing that specifically. I tried this particular setting with other images, and if you add it on top of the first stretch that you did, then it might be too much. Okay, so remember that, right? So we're double stretching here. Perhaps let's try one more time. I think that looks pretty good. I think we should leave it like that. Then we can click on close, and now our image is stretched permanently. Right now is non-linear image. Okay, and from here you can do several things. One of the things I always do is color saturation. In this case, you can leave this as the default settings and just play here with the slider. See, and Siril's trying to select specifically just the um, data here, just where the data is, trying to leave the background as dark as possible, which I think is doing a pretty good job, to be honest. Okay, I think that looks pretty good. So we can click on apply, and that will be it. That's our final image. Okay, but remember I said I'm going to show you two methods stretch the image, right? So this is one that was statistical stretch, and the other I just need to undo the changes. The other is generalized hyperbolic stretch. So for that we go to again image processing, stretches, generalize hyperbolic stretch. And this one I find it is a little bit tricky. It gives you some more granular control, of course, because it's not just one slider. However, it's easy to break it too. Sometimes you might be like almost there, and then you chase something, and then it screws everything up. And sometimes you might be able to undo what you did, but some other times it's too hard, and you will have to click on here, reset, and start all over again, and that's okay. Right? That's okay. There's no problem with that. So the first thing that I do here is we go to stretch factor. Right? I tap one time, two times, four times. We're stretching, trying to see the data, right? Trying to get there. As you can see, the bell where the data is, where all the data is contained, is expanding, right? So that's what we're trying to do. We're exposing the image right now, right? I think that looks pretty good. That gives us a good start, right? So now we need to highlight up a point here in the middle, try to align it. Sometimes it might be easier to see, if sometimes it may not, so you can always zoom in here too as well. Zoom in the graph. Right now we can see a little bit better for sure. So try to select a point in the middle so we can have a balance between highlights and shadows. So click on that point, and that will shift the curve. Right, and that I think did a pretty good change. Right, it balanced the overexposed areas, which is definitely good. And then we can play with the local intensity, local stretch intensity. Sorry, we can play that. We try to make that a little bit darker, just a little bit, just a little bit. Right, a little bit, not too much. It's easy to overdo as well. I think see that looks pretty good. And now let's see if we can dial down a little bit of the background, right? Try to make it a little bit darker, but no, don't go like full pitch black. That's definitely not how it should be. Ooh, I think oh, see what I mean? This is very finicky, very finicky. Right? It's very touchy. Let's see. Oh, nope. Let's try to bring it back. Yes, there. All right, let's see. Let's try numeric values. You can always enter numeric value. Oh, I think that did a pretty good job. Sometimes it's easier just to try with different values. I think that looks pretty good. Let's see, maybe 0.7. Not even 0.7. 0.007. Maybe there. What do you guys think? Remember, this is to taste. There is no right or wrong here. Right? Just play around. Play with the sliders, right? Play with the different values. See what you get. Right? What may look right for me may not look right to you, and as well, like if you have like a calibrated monitor, it may look a different way, or better or worse, right? So try to play around. Oh, I think that looks pretty good, very close to what I'm looking for. Yeah, yeah, I think so. I think that looks pretty good. Okay, the background is not pitch black, but it's definitely darker, right? You can see more than nebula. Unfortunately, I don't have too much data here, so it's hard to see the details. But yeah, I think that looks pretty okay. I think we can click on apply, and that's it. That's our final stretch image. So the last thing that you need to do is save the image. Right? So in order to do that, you can click on this icon here, this little like down arrow, and you can save it to anywhere on your drive. Right, and yeah, that will save it as the particular format you select here. You can export it directly to JPEG, FITS, PNG, or TIFF. If you plan to use this image on Photoshop or any other editing program, then I will definitely recommend to use TIFF, because that will keep the highest quality and resolution, so you can continue editing the image, right? And that's pretty much it, right? This is what I have for you guys today. I hope you find it useful, interesting, and hopefully not too long. I always say start with the videos are going to be short, and keep extending the the recording. But like I said, I hope you find it useful. and interesting. And thank you very much for watching. Right, clear skies. Take care.